Welcome to Penrose Learning, where we make understanding easy.
You begin by scanning the circuit for nodes and independent sources, then pick a reference node and assign current directions. Once done, label each resistor with its value and mark voltage polarities consistently. This avoids sign errors. Make sure to choose whether you'll apply KCL at nodes or KVL around loops first, because that decision shapes your unknowns. Finally, list unknown currents and node voltages on paper so you can start forming equations immediately. No hesitation, start writing. Once your unknowns are defined, write KCL at each non-reference node and KVL for independent loops, explaining signs as you go. Substitute Ohm's law, V equals R, to convert voltages to currents or vice versa. This makes equations linear in the chosen unknowns. Then collect terms and arrange the system in standard form, coefficients left, constants right, so you can use substitution, elimination, or a matrix solver. As you solve, track units and simplify fractions to avoid arithmetic mistakes. You finish by plugging the solved currents and voltages back into the original KCL and KVL equations to confirm they hold numerically. This validates your algebra. Next, compute power for each element, P equals VI or P equals I2R, and verify that total supplied power equals total dissipated power within rounding errors. If something fails, re-examine polarity assumptions, current directions, and algebraic signs. A common culprit is a flipped sign or wrong reference node. Correct the error, then resolve.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.